Good afternoon. My name is Michael Demby, and today I will be presenting my recommendations to conserve Indonesia's rodent population. Rodents are the most diverse group of mammals, consisting of 40% male diversity, and also consisting of 1,500 species. They can they have many different plans, from being rats to being porcupines and even being squirrels. They also typically arboreal or terrestrial, but they also typically have a diet of being herbivorous, but they can also be omnivorous, with one of the rodents on our islands being typically preying on earthworms. Here we see our eight species of concern, which have statuses of lower than least concern. Here we have the vulnerable Komodo rats, the near-threatened cream-colored giant squirrel, the horse-tailed squirrel, which is near threatened, and the edented Sulawesi rat, which has a conservation status unknown, as it was recently discovered in 2012. And here we have a map of all five of our candidate islands, being 1 through 5, with Island 1 being our large island and Island 5 being our smallest island. Here I'll give a brief overview of the steps I took to create this conservation plan. I quantified the island richness of each individual island by adding up the species present on an island. I then added up the total amount of species on each island to get the overall richness of our islands. I quantified the island populations in a similar way by taking each individual by finding out the individual population on each island, and I add those all together to get the overall population of our islands. I characterize diversity using two indices, the Shannon Diversity Index and the Reverse Simpson Index, and then I also characterize evenness by using the Shannon Evenness Index. To examine the relationship between island area and diversity, I compared the island area to the richness and population on each island, as well as I used the unique species present on an individual island as well to give it a little bit to also make it more unique from to separate each island's characteristics. I then evaluate the commonly used diversity patterns of enemy disturbance, diversity productivity, species area, and latitude diversity gradients to see if any of them explained and the diversity we saw on islands using the information we had from the bio using the information we had. But due to the nature of the BioBlitz survey, I was not able to adequately use you adequately describe the diversity and the picture of our island, and I just gave time to discuss the gaps of information we have on the development of the islands. I then made a conservation recommendation based on the diversity and community makeup of our islands. I determined a recommendation based on the amount of species present on each island, alpha diversity using the Shannon Index and the Reverse Simpson Index. I also use island biogeography theory and the presence of endemic and invasive species on each island, as well as Jared Diamond's assembly rules. Lastly, I also included a section of possible changes I would make to my recommendation for my recommendation based on if a certain environmental condition was revealed. Here's a table characterizing the overall diversity of our five islands. Island 1 had the highest richness and population of our five islands, and also carried all eight species of concern. We also had four unique species, as well as the highest Simpsons index and the highest Shannon index, but it also had the lowest evenness score of all of our five islands. Our lowest scoring island in terms of diversity observed was Island 5, which had only had three species present and 12 and a total population of 12. It also had the lowest amount of species of concern, as well as the lowest scores of Simpson Index and Shannon Index. But it also had two unique species not present anywhere else and had the second highest amount of species evenness. Here we observe the island area relationship to diversity. As you can see, island area was pretty correlated with richness and diversity. As you can see, species richness decreased as island island area decreased, and so did diversity. With Island 1, as you can see, Island 1 had the highest richness and diversity, while Island 3 had the lowest richness and diversity correlated to the and that correlated with their decrease in island size. For patterns of diversity, we weren't able to quantify uh, the other three patterns of intermediate disturbance because we lacked data on the frequency of disturbance on our islands. We also lacked knowledge of plant productivity on our islands, which meant we couldn't evaluate the diversity productivity relationship. We also lacked the latitude measurements of our islands so we couldn't observe the latitude diversity gradient pattern. But Indonesia is an equatorial country, so it can be assumed that the diversity gradient relationship uh, may not really be affected. That may not really be responsible for the community differences observed. These results we observe also correlate with iron bar geography and Jared Diamond's assembly rules. Island 1 had the highest area, and so it would make sense that it would have the highest richness because not only because of species area relationship, but also because it also has a lower extinction rate due to the amount of areas, the amount of space for each individual species. In contrast, Island 5 had the smallest area, and so it had a greater pressure for extinction for each individual species. So it makes sense in terms of island geography as well that would have the lowest population due to having a higher extinction rate. Look at these assembly rules. Island 5 also may not have Ras ratus, the black rat, an invasive species to Indonesia present because its small community prevents ras from invading. Here we can observe the abundance pattern of our five islands. As we saw, all of our islands had one dominant species present on the island. In islands 1 through 4, ras dominated the matrix, dominated our community, while island 5 had Paramelomes lorenzi dominating it. Common species were present on 4 to 5 islands, while rare species and threatened species were only present on 1 to 2 islands. We also know that a species abundance pattern is that organisms tend to be centered around their niche. However, we cannot test this, and we can't observe this with the limited data we have. We also Other consequences of our lack of environmental measurements include a lack of information about the abiotic part of our rodents niches, plant productivity on the island, which could help us derive the diversity productivity pattern, and also we lack the an idea about the quality and heterogeneity of our island ecosystems. Based on the information of our study, I recommend protecting islands 1, 3, and 5. By protecting R 1, 3, and 5, we can protect all 17 native species identified in our survey. Island 1 had the highest diversity indexes measured, and so it had a pretty high richness and diversity. Island 3 allows to spread risk of 12 species should anything happen to Island 1, including 5 endangered species. Although it only had three species present, Island 5 also makes a case to be protected because it had 2 species only identified on that island and it only had native species present. In addition, island biogeography and assembly rules also promote the protection of Island 5 as not only is it harder for rodents to for the native rodents on that island to migrate away from it because of their terrestrial lifestyle, it is also harder for invasive communities to invade to get into Island 5, as it has shown based on no ras not being present on the island. I recommend I recommend protecting other islands if Island 5's real reason why it had such a low population was because of its environment being degraded. By following this recommendation, I believe that we can protect Indonesia's native biodiversity, and preserve it for generations to come. Thank you so much. And here are the sources I used to make this study. Thank you.